How to solve linear equations. The concession stand problem. It's the big weekend. Your class is in charge of the concession stand at the homecoming game. After much conversation, you decide to sell hot dogs and hamburgers. You want to maximize the profit. A hot dog gives your class $2 in profit, while a hamburger gives $3 in profit. Based on your class's budget, the total number for hot dogs and hamburgers combined has to be fewer than 100. A hot dog requires 10 minutes to cook, while a hamburger requires 15 minutes to cook. The total amount of cook time that you'll have is less than 1,200 minutes. Determine the amount of hot dogs and hamburgers needed to make in order to maximize your profit. So your variables are going to be the amount of hot dogs and the amount of hamburgers you make. So we'll set x as hot dogs and y as hamburgers. Then your objective function, the objective is to maximize your profit. And if you're making $2 for every hot dog and $3 for every hamburger, your equation will be the profit, P, is $2 for every hot dog plus $3 for every hamburger. Then your constraints here, x plus y is less than or equal to 100. You would get this from the amount of hot dogs and hamburgers combined has to be fewer than 100. So it has to be less than or equal to 100. Then another constraint, 10x plus 15y is less than or equal to 1200. You would get this from a hot dog takes 10 minutes to cook, a hamburger takes 15 minutes to cook, and the total amount of time you have is 1,200 minutes. So 10 minutes for each hot dog, 15 minutes for each hamburger, and then this is your max time. So what you want to do is you want to solve for these equations, or solve for y, so that you can plot them on a graph. So x plus y is less than or equal to 100. Subtract x from both sides, you get y is less than or equal to x plus 100. Then you want to solve for y on the next equation, and so 10x plus 15y is less than or equal to 1,200. You subtract 10x from both sides because you're trying to solve for y. Then you get 15y is less than or equal to negative 10x plus 1,200. Divide both sides by 15, and you get y equals less than, or y is less than or equal to negative 2/3 x plus 80. So these this graph here, we'll have it going by tens because it fits pretty nicely. And so we'll go ahead and graph these lines. Y is less than or equal to negative x plus 100, and y is less than or equal to negative 2/3 x plus 80. So I already have them graphed. And so when you make that, it's less than or equal to. So the line, when you make these lines, all the region that is below both of those lines, because it's less than or equal to, is the feasible region. So this gray area now is the feasible region. And your critical points are going to be all the different corners in this feasible region. So your critical points are 60, 40, which is this point, 0 and 80, which is up here, and then 100 and 0 here. And then there's also 0, 0, but you can just leave that one out because you're not going to be wanting to make 0 hot dogs and 0 hamburgers. So now you want to find how much each of these profit you. So you'd plug 60 and 40, which is your x and y, into your profit equation here. So you'll find that when you plug in 100, 0, then your profit would be, you'd get 2 times 100 plus 3 times 0, which would equal 200. So the profit for having 100 hot dogs and no hamburgers would only be $200. Then if you were to use 0 hot dogs and 80 hamburgers, your profit would be $240, but you're going to have to make more than, you can't have 0 hot dogs. So the final answer would be 60 hot dogs and 40 hamburgers for a profit of $240. And so max profit is $240 with 60 hot dogs, 40 hamburgers.